Hi there, I'm Han. This is just another video of me solving the numerical problem. So given a random and of size n, return the majority element. So the majority element is the element that appear more than twice, more than n divided by 2 times, right? Um, you may assume that the majority elements always exist, right? So let's see, we can sort the array, right? We can sort the array, right? Because we know that the majority element will always be the element in the middle, right? That's why we can sort 2, 3, and 3, right? In the middle element is 3, right, which is the majority element. We can sort the second example, right? In the majority element, we have 3 and 3, 4, right? So the middle element is this one, right? Will also be the majority element. So we have the length, right, which is 8 divided minus 1 divided by 2, right, which is 3.5, and we want to plot that, right, which is the middle index here, right? So so that would give us the time of n log n, right? And that's not so good. So can we do this in ON, right? So not only that, we have n log n real time, but depending on the sorting algorithm, right? We would have like up to like ON space complexity, right? So can we do it in ON time in one pass and using constant space? So the thing is that if it is the majority element, then when we count, it will always go back to that element, right? So let's say we have a candidate of 3. So we only update our candidate if and only if the count is 0, right? So let's say we have we're looking at 3 here, right? So we set so because the count is 0, right, we can set our candidate to 3, right? And we keep going. And also, of course, before we move on, we need to also update the count, right? So if we see a different element, right, that is not equal to the candidate, right, we want to decrement the count, right? So we go here. Because the count is 0, right, we set our candidate to 3, right? So let's look at like a different example here, so it will be more convincing. So 2, 2, 1, 1, 1, 2, and 2, right? So count is 0, so we set a candidate to 2, right? This become 1, right? We see the candidate again, so we increment the count, right? We see a number that is different than the candidate, right? So we decrement the count, right? Same here to 0, right? Go to here. So now the count is 0. We update our candidate to 1, right? So obviously, if you just look at like this array, right? If you only look at this array, then of course we can see that 1 is the majority element, right? Because 1 appeared 3 times and 2 only appeared twice. So if the number is the majority element, and eventually we will get to it, right? We will like decrement the count of other numbers back to 0, right? And then update the candidate to be the majority number. Okay. So here, right, is 2, right? Oh yes, and when we update it to 1, we need to also increment the count here, right? So now we're looking at 2, right? It's different than the candidate, so we increment this to 0, right? And we move on. So now the count is 0, so we update our candidate, right? So the candidate will always be the majority element, right? Okay. So that is our strategy there. So let's code this up. So we need to have our candidate equal to the first element. Let's see. Are we guaranteed to have n is the nums at length, and n will be at least one, right? Yeah, because it is at least one. We can set it is equal to the first element, right? So we need to have our count equal to one, and for I equal to one, and if I'm length, plus, we can return the candidate again. And so that is our general setup here. We pick the candidate as the first element, right? So the car is one. So each car is zero, right? We just update. Yeah, if car is zero, we have to update our candidate equal to number I, and then increment our. So we will increment the candidate, right? If the nums I is equal to the candidate. So the candidate equal to nums I, right? We add one, otherwise we minus one. Right. So let's say we reach a count of zero, right? We can set the candidate to nums I, right? So now they are equal, right? We can add one to the, and otherwise, if we see like a different number, right? We have to decrement the count until we got to zero. Okay, and it worked. And we did really well with the display here, 99% also the time. So thank you for watching.